Hi, welcome to the Calculus 2 lecture series. And this is the unit number 2. In this unit, we are focused on the, to discuss the techniques of integration. All right, so this is the lecture number 7 for this lecture series of Calculus 2. And for the previous lecture, we talk about the integration by parts. Like we talk about, that's very important, integration skill. So for this lecture, we're going to talk about the trigonometry integrals here. So we're going to talk about the different way dealing with the trig functions. So basically for this lecture, I'm going to divide it into 4 different parts. And each part, we're going to talk about different way to deal with the trigonometry functions here. All right. Okay, so now let's go ahead go to our lecture notes and start to talk about. Okay, so like we talked about before, this is the, for this lecture sections we talk about is the trigonometry integrals here. So basically we want to learn how to evaluate. So how do you want to evaluate integrals here, and whose integrand are the power of sine and cosine, tangent, and secant, tangent, secant, and then cotangent, and cosecant here. Okay, so we're going to talk about all the different ways with, how do we involve the, the integration involve some type of the powers, right? So the sine to the square or cosine to the cube, those things. Okay, so the first things we're going to talk about, so in this part 1, we talk about is how do we deal with the integrations is with the sine and cosines here. And then the key things here is one of the power is odd numbers here. Okay, so could be n be odd number, n is odd number, or both of them is odd numbers. Doesn't matter. So one of them is odd number. So the several key things when we try to do this type of the integration. So the few key identities, the 3 key things we need to follow basically is the one of the key identity for the trig functions we're going to use. It will be x squared. I'm sorry, it's not x squared. So this will be sine squared x plus cosine square x is equal to 1. The reason why this is the identity, because we can use this identity to change the function of sine be a function of cosine, or we can change the cosine to be a function of the sines, right? So we can just say it's 1 minus sine square equal to the cosine square, or 1 minus cosine square equal to the sine square. So this is the one of the key identity we're going to use. Now also for here, another here is we're going to talk about is a key derivative. We're going to use for this type of the situation. So what is the key derivative? This is our very, very fundamental. We know that if I want to take the derivative of the sine x, what that going to be? It's a cosine x. Here, then if I want to take the derivative, so if I want to take the derivative of the cosine x, what that will be the negative sine x, right? So you will see later when we try to do the examples, then you will see why we need this the derivative, key derivative formulas here. So then the last techniques we need is we need to use, that's what we learn. So we need to use the U-sub, right? So that we need to use U-sub integration technique. Okay, so those are the three basically the step and the key tools we use. So we know that the U-sub is the type of the integration skill we introduced first, right? So that's the first integration skill, and we say we use it widely. Okay, so let's take a look at the first problem here, right? So how is these three things? Okay, so first thing here, this is a cosine 5x. So even I don't have a sign, that could be ones, right? So that doesn't matter as long as one of them is what? One of them is odd numbers, right? So here, this is odd number. The reason why I want odd numbers is so here. Okay, so let's see here. So this is a cosine 5x, right? The x to the fifth. The reason why, because it's odd, I can take one out. So this one will be cosine 4x times cosine x, right? So it's a cosine to the fourth power times cosine x. All right. So now also because cosine 4x is here, all right, so this will give you is cosine square x to the square times cosine x. Okay, so now I know the cosine to the squares, right? So I can change this one. I use the first identity, cosine square will be 1 minus sine square x. Then this is cosine x. So here is the squares here. Okay, so now let's take a look, all right? Okay, so this is the where we say the key identity I use it here. So let's take a look at these integrations here. So this is the integrator, right? So here I can change, this is a cosine square x to the square cosine x dx. And then this one will give me is 1 minus sine square x to the square. Then this is cosine x dx here. So now I'm going to use U-sub and my key, my key derivative formulas, right? So in here I have this cosine x here, right? Okay, so by my U-sub here, all right? So by my U-sub, then I can say U is equal to sine x. Okay, so U is equal to sine x. So now I know what is here. So du will be equal to sine x. You take the derivative will be what? It's cosine x dx. So did you see here? That's where is this one cosine x come out, because this number will become what? Will become du's here. Okay, now I can, by the U-sub, I will say, okay, so this one's here. So this is 1 minus u square to the square. Then here is what? du, right? Right now, then we change this complicated trig integration to just a very simple. So now I will just try to FOIL it. So this is 1 minus 2u squared plus u fourth, right? So you FOIL it and du, and then you can just take this is very easy integrations, right? So you can just, if you want, you can separate to 3 parts, right? U squared du plus this is u fourth du. Then this will just be the simple powers rules, right? So this will be equal to the u minus 2 plus 1 is 3, so it's 2/3 u the what? U the cube, then plus u to the fifth plus c. Now you substitute what is your u, so this will be the sine x minus 2/3. Then this is the sine x to the cube plus 1/5 sine x, the whole thing to the 5th plus c. Some people, you know, they like to write like this way. This is a 2/3, so some people like to write a 3 here, like this way. That will work also. That's the different way to write the power, the exponents in the sine function. So as you can see, that's why I said when we do this type of the problems, right? So the key things here are those, you know, the key identity we use, right? So remember the key identity and, you know, the key derivatives, right? And U-sub. All right. Okay, now let's take a look again. The next one's here. Okay, so the next one, you take a look here. We say, hey, this is the sine 5x and cosine 2x. How? I have a odd number here. So that's good because I know if I have an odd number, so let's try to separate this odd number. So this one I can say here, take a look here. So this will be sine 4x, right? X to the 4th power times, take one sine x out, right? Then here, this is a cosine square x dx, correct? All right, now I use the identity again. So the sine x to the 4th power will be 1 minus cosine square x to the what? To the square, right? Then I have a sine x cosine square x dx, right? So it's the same thing because the sine force, right? Sine the x to the 4th power is equal to the sine the square x, the whole thing square. Then the sine square x is 1 minus cosine square x by the Pythagorean identity for the trig functions, right? Okay, so now let's rearrange this a little bit. So here, this is 1 minus the cosine square x to the square. Then here, this is cosine square x dx. Then I have this is sine x dx. You see here, I have this one separated out here. Now I can use the U-sub again, right? So now the U-sub here will be what? So you can say, hey, now my U-sub here will be U is equal to what? Cosine x. Right? So now in here you say du is equal to negative. The cosine x take the derivative is negative sine x dx. See here? All right, so the next, so now you have this sine x here, it's pretty good, and then move the negative sign to, so negative du is equal to the sine x dx. So I get this part, right? So that's why you take one sine x out. Okay, now I can substitute the U-sub here. So this will be 1 minus the U square to the square, then U square, and right, so I'm sorry here, I put one more. So the cosine, so here, like this way, right? So I wrote one more dx here. Okay, then the sine x dx is what? Negative du's, right? So I put a negative du's here. All right, okay, so now the same things here. Be careful about your algebra, you foiled it. So this will be 1 minus 2u squared plus u fourth times u squared du. All right, so don't forget this negative sign. So this will be u squared minus 2u fourth plus u sixth du. All right, okay, so now this one become a very simple integration. So it will be minus, be careful about the parentheses. So this is u cubed over 3, and minus this is the fourth, right? So it's the power through is 5, so this is 2, u to the 5th, then plus u to the 7 to the 7th, right? All right, so then it's a plus c here, and now you can plug, so what is u? U is cosine x, so you can say this is negative 3 cosine x to the cube. negative, negative, plus, right? So plus is 2/5. Then this is cosine x to the what? 5th power. Then negative 7. So this is cosine x to the 7th power, right? And the plus c is here. So that is, you know, what we call this first type of the trigonometry evaluate, the integration. Okay, so now let's take a look here. This one looks it's kind of a little bit complicated. You say, hey, it's the square root of x. That doesn't matter. And as long as one of them is odd, so I noticed this one, what? This one is odd, right? So the square root of x even is not the integer, but that's fine as long as I got one odd ones here. All right. Okay, so now we can do the same way. Did you see here, like from this problem? So we use all the 3 properties, right? This is the what? This is the this is a key identity and the t derivative. See here, right? So derivative and then the u sub, right? So we used all these 3 properties here. Okay, now so here let's do this one. See here. So this one is the same thing. See here. So let's try again. So we will say sine. Okay, so let's do this. All right. So let's here. So this is okay, so the square root of cosine x, so this will be cosine x to the negative 1/2. And sine cube, I can separate it as a sine square times sine x dx, right? I break it. That's why it's odd numbers matter. Okay, now what is the next? Next is the identities, right? So this is cosine x negative 1/2. Then this is 1 minus cosine square x sine x dx. Haha, I used the identity. So what is the next? U sub, right? So I say U is equal to cosine x. Okay, U is equal to the cosine x. So let's do here du. Remember the du is what? It's negative, right? Sine x dx. I have a sine x dx here. So what I can do, move the negative sign to the front. So this is a negative du is equal to the sine x dx. Correct? Okay, now let's do it. Okay, so now let's see here. So this will be equal to, so cosine x, so this is u to the negative 1/2. Then this is 1 minus u square. What is here? Du. And don't forget the negative du's, right? So don't forget this negative du's here. All right. Okay, now the integration becomes pretty straightforward. Now let's FOIL this out. So this is negative. So this is u to the negative 1/2. Then minus u to the what? 3/2. Right? So the du, okay, now integrating. So by the power rule, so this is negative 1/2 plus 1. So this is 2. U is equal to the 1/2. Right? And then this is a minus 3/2 plus 1 is 5/2. You flip. So it will be 2/5. Then u to the 5/2, right? Use the power rule. So assume everybody should be very familiar with that. Then plus c. Now, last step, substitute the cosine back, right? So this is negative 2. And then here will be the cosine x 1/2. So square roots, correct? Okay, and then plus minus is plus 2/5. And cosine x 5/2 plus c. All right, so those are the 3 examples to show you if one of the sine cosine function have odd numbers, and then how do you do? So it's very convenient. If they have odd number, you can always separate one them out and then use the derivative and then use sub. Okay, so if So we said as long as one of them is odd numbers, right? So how about, we said how about in here, if both of them, right? So if both of them are even numbers here, so I don't have any odd numbers here. So what I need to do, okay? So the things here we need to do here. So just like the others, we have the few key identities we might need to know. So key identities here. Okay, so the key identity, so for the one of them is odd number, we use the Pythagorean's identities, right? So the key identity, we use the, for the, if they are even, we will need to use either we call it a double angle or half angle. So the, in here we have a sine square x, okay, is equal to the 1/2 cosine 1 minus cosine 2x, or you have a cosine square x. So this is what we call as half angles, right? It's the 1/2 then 1 plus cosine 2x, okay? And then the next thing here we need to do is we also need to have some key integration formula. So the some key integration formula we will need is like, so how about if you integrate cosine ax dx? So we know the cosine when you're integrating, it will be what? It will be sines, right? But in here, how about if I have this extra constants a? So we know this integration will be what? It's sine ax divided by a plus 6, right? So the same way, if you integrate sine ax dx, and also if you have some constants here, then the integrations here, I know the sine integration will be cosine, so here will be negative cosine ax over a plus c. Of course, from here, because this is pretty simple, you just kind of you can use the U-sub, but if you remember that will be a lot easier instead of use U-sub. Okay, let's take a look at what I need to do here, right? So what do I mean here? So, okay, so in here, so I have a sine square x, right? So this is what? This is even. Because this is even, I cannot take it out 1. Because I take it out 1, then the remaining power will be odd. Then for the odd, I cannot use the Pythagorean identity, right? So that's why we need to use the half angle formula. Okay, so the sine square, all right? So this one here will be pretty easy. So this is 0 pi. Okay, sine square, I just use here, this is 1/2, 1 minus cosine 2x dx. All right, so here now I'm going to put the 1/2 out, then this is 0 to pi, then this is 1 minus cosine 2x dx. Okay, so now let's do here. So this is 1/2. Okay, so this ones here will be x minus, right? So cosine, remember I will say that now if you remember cosine when you're integrating will be sine. And then in here, just need to be careful if they have a constants, and then you need to divide by constants here, right? Okay, so now let's see here. So what is this integration? So this is cosine 2x, cosine, it will be what? Sine, right? So you say the sine 2x. And because I have, this is 2, so what I need to do here, I need to divide by what? Divide by 2. Am I right? All right, so here, then in here, you put the upper bound and the lower bound here. Okay, so now if you, I think I assume everybody know how to right? Put the upper bound and the lower bound. So this will just be 1/2. Then this is the pi minus sine 1/2 sine 2 pi, right? So then minus 0, then plus 2 sine 0. So or if you want, if you don't want to mess up your, so this is minus, right? So then we know this is 0, 0, 0. So what is the answers here? It's 1/2 pi, right? Because I know this will become, this is 0 and this is 0, right? So it's a 1/2 pi. All right. Okay, so now let's take a look at our next ones here. So the next one is a cosine 4x here. All right. So for cosine 4x, all right. So here we say, oh boy. So here this is another, right? So the even numbers here. Okay. So cosine 4x. So let's do this. All right. So let's start with a cosine 4x. X to the fourth power, right? So it's a cosine square, the whole thing square dx. And then I apply the half angle. So this will be 1/2 1 plus cosine 2x, the whole thing square dx. Right? Okay, so now in here, let's say 1/2 square, so it's 1/4. And then I need to FOIL this, so this is 1 plus 2 cosine 2x, all right? Then plus cosine square 2x dx. All right, okay, so now I can separate that. So you will say that this is 1/2, 1/4, then this is 1 dx plus and 2 times the cosine 2x dx, then plus cosine square 2x dx. Okay. So when you do this, you find out, all right, this one, okay. So this one is, so this is true, right? So this one is easy, right? So this one is easy. So this integration is what? This one will be x. And this one is easy, right? So this integration is easy. So this one's here. What is this integration going to be? This will be equal to the 2 times, right? So this is a cosine 2x. I know the cosine integration will give you what? Sines, right? So it's 2 times 2. Then this is sine 2x. And now you are in troubles now because I have this one. It's a cosine. What? It's a square again, right? So what I need to do here, I need to use a double angle one more time. So this integration will be equal to 1/2 1 plus cosine 2x dx. Am I right? Okay, so now I'm just doing this blue ones, right? So this one will be 1/2. And then here, this is 1 plus cosine 2x dx, right? Okay, so this one will be 1/2. Then this is x, right? Then cosine 2x is what again? 2 to the what? Sine 2x. All right, so this blue one, so I need to use the, the double angle, the half angle again. So now in here, let's be careful about your algebra. So this is 1/4. So this is x, and here is here. So this is what? This is sine 2x. Then this is plus what? Plus 1/2 of the x. Okay, and so this is what? Plus 1/4, right? So this is we're going to have 1/4 cosine the square okay. See here, I made a mistake here. Okay, so be careful. Okay, so this is a cosine 2x. Well, I used a double angle, right? So need to be careful. What is here? This will become cosine. Let me see, I was not careful. So cosine 4x. All right, so now because the double angle for 2x is 4x, right? So this will be what? Will be cosine 4x here. All right, so now is better, right? So now in here, this is x again. So what is this one's here? Okay, so in here, this is the sine. So cosine 4x, so it's 4 here. Then what is, so this is the sine. So it's a sine 4x, right? So cosine 4x, when you take the in, so this will be sine 4x. That's why we need to be very careful here, right? So that's the force here. Okay, so now let's try to do again. So this is 1/2 of x, okay? And now here is 1/2 plus times 1/4 is 1/what? 1/8 sine 4x plus c. All right, now we are almost done. Okay, so I take the 1/4. So here x plus 1/2 of the x. So what is this? 3/2 of the x, right? So times 1/4. What I have here? 3/8x. Then plus 1/4. This is sine 2x over 4. Then plus 32 sine 4x plus c. All right, so be very careful. Like in here, like I mentioned, I was not careful. I made a mistake. So from here to here, right? Because sine 2x, then you use the half angle. So the 2x is the half angle for 4x, right? So here has to be 4. All right, so be very careful here. That means why do the double angle or the half angle twice? All right, so that is the first lecture, the part number 1, when we're dealing with the sine and the cosine combination. All right, so for each one here, if one of them is odd, then the identity, the key identity we use is the Pythagorean identity. If both of them are evens here, then we need to use the double angle, or some people call the half angle identities here. And then, remember those like a simple integration. If you have some constants like cosine ax, then make sure you divide by the constants a here. All right, that's it. And so the next things here, our next part, we're going to talk about, how about if we have like a tangent and the secant, right? So in here, we already talk about the sine and the cosine combination. And then the next part, we're going to talk about the secant and the tangents. And so what type of the identity, what type of the key derivative or integration we need to know. All right, that's it. It's very fun. And I think it is interesting integration skills here. All right, nice talk to you, and talk to you in our next lectures here. Okay, bye.